What if I told you that a 2,000-year-old philosophy could be the key to solving one of the biggest problems in modern artificial intelligence? Well, thousands of years ago, the Greek philosopher Socrates used a method of constant questioning to help his students find the flaws in their own logic. And today, something very, very similar is being used to teach AI how to do the same thing, to self-reflect, making them smarter and a whole lot more reliable.
So here's our roadmap for this breakdown. First, we're going to look at why AI makes mistakes in the first place. Then, we'll take that trip back to ancient Greece to understand the Socratic method. After that, we'll dive deep into how this new framework called SSR actually works, see the proof that it's making AI smarter, and finally, we'll talk about why this is such a huge deal for all of us.
All right, let's get right to the heart of the problem. You see, even the most powerful language models out there, think GPT-4, can still make tiny, simple mistakes when they're trying to reason through complex problems. And here's the real kicker. Those tiny, seemingly harmless errors can snowball, leading to a completely wrong answer in the end.
The research paper itself puts it perfectly. They call this a cascading error. Just think about that. It means in a long chain of reasoning, all it takes is one bad link. Just one. And that mistake spreads like a virus, contaminating everything that comes after it. The whole thing just falls apart.
The best way to picture this is with dominoes. That first little mistake is the first domino to fall. Once it's pushed over, it triggers a chain reaction, and the entire line of reasoning just collapses, one step after another. It doesn't even matter if all the other dominoes were set up perfectly.
And here's a perfect example of that in action. Look at this simple math problem. The AI needed to find two numbers that multiply to 24 and add up to -13. The correct answer is -8 and -3, but somewhere in its reasoning, it made a small slip. That one little slip sent the rest of its calculations down a completely wrong path, leading to a final answer that was just flat out wrong.
So how in the world do you fix a problem like that? Well, what if we could teach the AI to act like one of Socrates' students, to pause, to question its own work at every single step? That's exactly the idea behind this solution, a method for teaching AI how to self-reflect.
And it has a fitting name, Socratic Self-Refine, or SSR for short. The core idea here is to give the AI a structured way to correct itself. So instead of just blindly pushing forward, it learns how to check its work as it goes, constantly questioning and fixing its own logic.
Okay, so how does this Socratic method for AI actually work under the hood? It's actually pretty intuitive. It all breaks down into 3 key steps. So let's walk through them one by one and see how this AI Socrates actually learns.
Those 3 steps are decompose, verify, and refine. First, the AI breaks a big, complex problem down into a bunch of smaller, bite-sized questions. Then, it verifies each of those smaller steps by trying to solve them over and over to see if the answers are consistent. And finally, it refines its work by finding the weakest link, fixing it, and then generating a brand new, much more reliable chain of logic.
Let's look closer at that first step, decompose. So instead of spitting out one long, tangled monologue, the AI restructures its own thought process into a clean, clear Q&A dialogue with itself. You know, stuff like, what's the first thing I need to do? Okay, what's the answer to that? And what's the next logical step? This turns a chaotic mess of thoughts into an orderly conversation, which makes it way easier to check for mistakes later.
Next up is verify. Now, this is where it gets really clever. For every single one of those little sub-questions, the AI completely ignores its previous answer and tries to solve it again from scratch, multiple times. If it gets the same answer every single time, great, it's confident in that step. But if the answers are all over the place, say it gets 2 different results over 3 tries, that's a huge red flag. It signals that this step is probably where the error is hiding.
And that brings us to the final step, refine. The AI zeroes in on the step with the lowest confidence score, the one where the answers were the most inconsistent. It then takes the most common answer from the verification stage and uses it to fix the mistake. From that corrected step, it generates a whole new, logically sound path to the solution. It's like performing precision surgery on its own logic, fixing the root cause without having to start all over again.
So, all this theory sounds great, but does this Socratic method actually work in practice? Does it really make the AI smarter? Well, let's let the data do the talking.
Check out this chart. This shows performance on the AME benchmark, which is based on a seriously tough high school math competition. You can see that other self-correction methods like self-refine and debate hover around a 63% accuracy rate. But SSR, it jumps all the way up to almost 70%. That's a really significant improvement over the other techniques.
And get this, the researchers found that SSR can lead to a relative accuracy improvement of over 67% compared to the AI's initial attempt. Now that number is staggering. It means this isn't just about making tiny tweaks, it's a method that can fundamentally and dramatically improve the reliability of an AI's reasoning.
Now, helping an AI score better on a math test is cool and all, but the real importance of SSR goes way, way beyond that. This breakthrough has some pretty profound implications for the future of artificial intelligence. What this really gets at is building AI systems that we can actually trust. Because of SSR, their reasoning isn't just more accurate, it's also more reliable. And maybe most importantly, because the entire thought process is broken down into a step-by-step dialogue, it becomes much easier for us humans to understand how the AI reached its conclusion. This massively boosts its interpretation or transparency.
Just as the paper's conclusion says, the real value of SSR is that it's a step towards making AI reasoning something we can actually interpret and control. We're moving away from the black box model, where we only see the final answer, to more of a glass box, where we can actually look inside and watch the thinking process unfold. That's a huge leap forward for our ability to control and trust these systems.
So, when an AI starts to question itself, just like Socrates did, it's more than just a technical achievement. It opens up a whole new way of thinking about what intelligence even is. An AI that can reflect on its own thinking. Where does it go from there? What comes next? That is a question we're thinking about.